Hey, Mr. Van here. This is from day 4, and it's called distribution types. That's the cool down we're working on. This one's going to be a quick one. Really, this is just understanding these different definitions. There's a few different ways that we can describe a distribution. And our distributions, when we talk about distributions, we're looking at dot plots or histograms. Box plots, we can see the shape of the distribution kind of based on how long the sides on the box plot are or how wide the box is. But you don't get quite as clear of a picture. Anyway, there's a couple of different types of distributions. First of all, we have distributions that are symmetric. That means that the left and the right side of the distributions look the same. Like we could put a line right down the middle and the left and the right look pretty much the same. Now, with real data, nothing is ever going to be absolutely perfect mirror image on the left and right, but that doesn't really matter. As long as it's pretty close to being the same on the left and right, we're going to call it symmetric. Now, in the symmetric category, we have a few different types of graphs. We have what we call the classic bell curve. Now, you can see that in dots, you can see it as a line, or you can even see it in histogram with bars. But a bell curve has one strong peak right in the middle, and then it gets shorter to the left and shorter to the right, and it's kind of shaped like a bell. You know, like if you wanted to draw a bell, anyway, it's shaped like a bell. The next one is uniform. That means that everything looks the same. All the way across, you have the same height. Again, it doesn't have to be perfectly the same. It's not going to be exact. However, if you have pretty much a flat graph, every bar is the same height, or you have the same number of dots, pretty close, we're going to call that a uniform distribution. Now, the bell curve was where we have one big strong peak in the middle. A bimodal distribution, we have two different distinct peaks. Again, nothing has to be absolutely perfect left and right to be symmetric, but bimodal means we have two strong, different, distinct peaks in our graph. Now, the other main category is a skewed distribution. Now, these terms might feel backwards to you. That one there on the left is skewed right, and the one on the right is skewed left. I probably should have flipped those around when I drew this, but here we are. Anyway, skewed right means that we do have a strong peak, but then it drops off really sharp on the left, and it sort of trails off on the right. We have a lot of data to the right of our main peak, not very much to the left. Skewed left means we have one strong main peak, not very many other data points to the right. We have a lot of data points to the left that are just kind of stretched out. Skewed left, it's stretched out to the left. Skewed right, it's kind of stretched out to the right. The mean, the average, kind of gets pulled to the right a little bit. This is like an outlier situation. Over here, the mean gets pulled to the left. Again, another outlier situation. All right, so in your cooldown, what you have to do is you have to look at each of these four distributions and you have to label it as symmetric or skewed. That's the first thing you're looking for. Is it symmetric or is it skewed? Now, in the symmetric category, is it a bell-shaped distribution? Is it a uniform distribution? Or is it possibly bimodal? If you're in the skewed distribution category, it could be a bell. Well, it's not bell-shaped. If it's skewed, it's possible you can have a bimodal that's skewed, but typically not. Again, no data is perfect. Let me know if you have any other questions.